Every developer knows this feeling. You submit a pull request, and then you wait, and you wait some more. And then finally get feedback like, looks good to me. Except it's been a week, and the branch now has 50 new merge conflicts. And it's not just slow reviews, it's the friction across the entire workflow from PRs to pipelines and finally into production. This slows teams down, and there has to be a better way, right? Well, that's where AI code review comes in. Today, we'll break down what it is, why developers are using it, and how humans still play a critical role. AI code review is the use of AI to analyze software. Pretty self-explanatory. And instead of relying on only human reviewers, AI tools automatically scan code to detect problems and even recommend fixes. These systems use machine learning and large language models, or LLMs, to recognize patterns. These patterns appear in code, and they can identify things like security vulnerabilities, or poor coding standards, or style inconsistency, and even performance issues. Some tools can even generate explanations and corrections. If you're wondering why this matters, modern software development moves incredibly fast. Teams are working with massive code bases, and reviewing every change manually takes a lot of time and can introduce human error. So let's unpack some benefits of using AI code review. AI helps developers do much more than just speed up code reviews. It also improves consistency across teams. So think about it. Human reviewers may interpret coding standards differently, especially across larger teams. One reviewer might focus heavily on readability, while another prioritizes performance or security. AI tools, on the other hand, apply the same standards every single time, helping teams maintain cleaner, more uniform code bases. Another major advantage is developer learning. Modern AI review systems don't just flag what the problems are, but they also flag why they're happening in the first place. So we can suggest better alternatives. And that turns the review process into a learning experience, especially for junior developers. Instead of waiting for feedback from senior engineers, developers can review immediate guidance while they write the code. Over time, this creates stronger coding habits. Last but definitely not least, AI code review helps teams reduce technical debt by catching issues earlier in the life cycle, when they're faster and cheaper to fix before they turn into production problems. Okay, so how does AI code review actually work? There are a few core technologies that AI code review is built on top of. First up is static code analysis. This means reviewing code before running it. It looks for syntax problems or security risks, violations of coding standards before deployment. Once the static code analysis is performed, among many other inputs, AI tools can then take this information to recommend improvements or a new course of action. Another layer is dynamic code analysis. Unlike its static counterpart, this involves testing the software while it's running. It helps uncover runtime vulnerabilities, performance bottlenecks, and behavior that may not be visible in static analysis. A common form of this is called Dynamic Application Security Testing, or DAST for short. This stimulates real-world attacks by sending inputs to a running application and observing how it responds. Any unusual or insecure behavior is then logged for review. We also have rule-based systems. These enforce coding guidelines and best practices. For example, traditional tools like linters can detect formatting mistakes or inconsistent code styles, and they help maintain consistency across development teams. And they're often combined with AI models that understand deeper context. With that in mind, finally, we have large language models. Traditional code review tools rely mostly on fixed rules, so anywhere from static code analysis to rule-based systems, and they can catch formatting issues or known patterns, but they don't truly understand the meaning or context of the code. Large language models, on the other hand, are trained on enormous data sets that include programming languages, documentation, APIs, and even developer discussions. And as a result, they can recognize patterns in code in a much more contextual and meaningful way. Modern AI code review systems can also extend beyond the code base itself by using external tools. So instead of relying only on what the model learned during training, these systems can connect to developer environments, testing frameworks, documentation, and even the web in real time. This makes the analysis more up to date and contextually aware. As with most things in life, AI code review isn't perfect. Let's unpack some considerations. One challenge is over-reliance on AI. So developers can start to depend too heavily on automated feedback and may stop thinking critically about the deeper architectural decisions or system design. Another issue is context. AI tools may struggle to fully understand project-specific goals without the necessary information. And this is why context engineering is so important. That means carefully structuring the information you provide to the model so it can generate more relevant and accurate outputs. There's also the problem of false positives and false negatives. Sometimes AI will flag code that isn't actually an issue, and other times it can actually miss real vulnerabilities entirely. So this is why human oversight is still essential. AI can support and accelerate the review process, but developers are still responsible for final judgment. If you're intrigued and you want to get started, there are a few best practices you can follow and some practical moves when adopting AI code review. It starts with choosing a tool that fits your development stack, something that integrates well with your existing systems and workflows. From there, it's important to configure your coding standards so that AI understands how your team writes and reviews code. This helps align its feedback with your expectations instead of generic suggestions. And these standards are often evergreen, and they're maintained in dedicated instruction files for both developer and AI tools to reference. Third, we have integration. So when the tool is connected directly into your development environment, often this is inside of an IDE or it's part of a pull request. Once it's in place, teams begin tracking code quality signals. So these are defect rates, review turnaround times, and vulnerability detection. This is what shows whether the system is actually improving the development process or it's just adding noise. And throughout all of this, the most important principle is keeping a human in the loop. So human review has to be part of this entire flow. Clearly, AI code review is transforming software development, but the key takeaway is that AI is most powerful when paired with human expertise. So our human judgment, and when we're evaluating trade-offs, and our creativity, as well as our understanding of nuance and context, combined with AI's speed and analytical capabilities, are what produce the best results. If you enjoyed this video, make sure to like and subscribe, and let me know in the comments what topic you want to see next. Thanks for watching.